Hi Calculus, let's go ahead and work through some of these questions. You can scroll through just the ones you need. So question 16, we've got the derivative and it is the absolute value of x minus 2. So notice that at x equals 2, the derivative will be the absolute value of 2 minus 2. We'll do this. The derivative is 0. So it would be a horizontal tangent line. And otherwise, so for all other x's, and this is how you can write your corrections, the derivative is positive, which implies that f is increasing. So it would be increasing everywhere, so it can't be A, it can't be B, it can't be C. It's between D and E, but at 2, I need a horizontal tangent line. So when I zoom in there, I would get a slope of 0. Here, if I try to zoom in, it's not even continuous. So, correct answer is E. All right, question 17. What's the area of the region enclosed by the graphs of f of x and g of x? So we need to start by finding A and B. So we can see where these two graphs intersect by setting them equal to each other. I am going to go ahead and get everything on the right-hand side to make the x squared positive. And then I would need to subtract x, so that would give me negative 6x here. So I could factor out a 2x, which gives me x minus 3. So my my intersections are at 0 and at 3. And so then I'm going to go integral from x equals 0 to x equals 3 of top minus bottom dx. To figure out which one's top, I can plug in a number between 0 and 3, like x equals 1. I see that f of 1 is 1 minus 2, which is negative 1, and g of 1 is negative 5. Negative 1 is larger, right? So f is top, g is bottom. You really don't have to do that. If you want, you could just pick one and then take the absolute value of your answer at the end. So I've got top minus bottom dx. Let's clean it up. So that's negative 2x squared. Then I've got x minus negative 5x, so that'll be plus 6x dx. I'm sorry, I don't know why I put a 2 here. That should be a 3. All right, so now we're going to antiderive term by term. So this will be negative 2/3 x cubed plus my new power here is 2, and 6 divided by 2 is 3. I'm going to evaluate that at x equals 3 and x equals 0. So I've got negative 2/3 times 3 cubed plus 3 times 3 squared. Minus, if I plug in 0 for x, I get 0 for both terms. So cleaning this up, negative 2/3 times 3 cubed is 27, plus 3 squared is 9, plus 3 is 27 as well. So 3 goes into 27 9 times. Negative 2 times 9 is negative 18, plus 27 is 9. All right, question 18. For the function f prime is 2x plus 1 and f of 1 is 4. What's the approximation for f of 1.2 found by using the line tangent to the graph of f at x equals 1? So as soon as I see that, I'm going to think point-slope form first. Notice that there's your x1, y1. To find m, we need f prime of 1, and they even gave us f prime. So f prime of 1 will be 2 times, I'm plugging in here, 1 plus 2, which is 3. So my tangent line equation is y minus 4 equals 3 times x minus 1. And then I want to use this to approximate f of 1.2. So we'll plug in 1.2 for x and solve for y. I would get that, right? If I plug in 1.2 and add 4. So then, let's see, 1.2 minus 1 is 0.2 plus 4. 3 times 0.2 is 0.6. So I am getting 4.6. Okay, we have f of x as this cubic function. We want to know when f is concave up. So for concavity, check the second derivative. First derivative is 3x squared minus 12x. Second derivative is 6x minus 12. Set that equal to 0. Let's solve by factoring. So x equals 2 as a possible point of inflection. We're going to make a number line with f double prime and f. If I plug in a value less than 2, like 0, I get a negative value for f double prime. And I don't see any even multiplicities, so we get a positive value if we plug in something greater than 2, meaning that f goes from concave down to concave up. We wanted to know concave up, so that would be x is greater than 2. All right, question 20. It says we were given g of x, and then it says that f is g prime of x, and then we want to find this definite integral. So f is the derivative of g. That means that g must be an antiderivative for f. Let's write that statement. G is an antiderivative of f. So if I want to find this definite integral of 1 to 3 of f of x dx, then that means I need to antiderive, which an antiderivative is g, and then evaluate, right? So antiderive, and then evaluate this at x equals 3 and x equals 1. In other words, g of 3 minus g of 1. So let's do that. G of 3, I'm going to plug 3 in here, will be 3 squared minus 3 times 3 plus 4, minus, then I need to find g of 1, so 1 squared, which is 1, minus 3 times 1 plus 4. Let's see, notice your 4's cancel. So I've got 3 squared, which is 9, minus 3 times 3, that's 9. So all I need to do here, let's see, 1 minus 3 is negative 2. So final answer is 2. All right, 21 is a really good one. We'll talk more about this when we do our graphical FRQs, but it says the graph of f prime, the derivative of the function f, is shown above for the closed interval 0 to 10. The areas of the regions between the graph of f prime and the x-axis are 26 and 4, respectively. They've shown those areas. If f of 0 is 2, it's the max value, so it's the absolute max y value of f on that closed interval. So remember, when we do absolute extrema, we make a table, right? And we label it x and f of x. And we need to include our endpoints and any critical points. And a critical point is where your derivative is 0. So I'm going to call this, let's say this is like x equals 5 and this is x equals 8. We're not going to need those x values, just so that we have more of a concrete kind of frame of mind here. Okay? All right, so our critical values are, let's say, 5 and 8. However, we're looking for the absolute max. And right at 8, I see that f prime changes from negative to positive, meaning that f is changing from decreasing to increasing, so that would create a relative min. So I really don't need to include 8. So I'm just going to include my endpoints of 0 and 10 and my relative max of 5. Okay, now here's kind of the twist. Now we need to figure out what f of x is at these values. We know that at 0, f is 2. Okay, we're going to have to figure out what f is at 5 and 10. Okay, and here's what I want you to do. I want you to think FTC rearranged, because you're given one function value, asked to find another. All right, so FTC rearranged says f of b equals, write this for me, f of a plus the integral from a to b of f prime. I'm going to do this t dt. Okay, so what we want to know is like f of 5 and f of 10. So I'm going to let b be x, and let a be the given x value of 0. So let's plug this in. So I've got f of x equals f of 0 plus the integral from 0 to x, a to b, of f prime of t dt. Okay? Now f of 0 is 2, remember that. So I'm filling this in now over here on my table. Okay? So f of x is equal to f of 0, which is 2, plus the integral from, look at that, 0 to x of f prime. And remember, there's two ways to find a definite integral. One is to antiderive, one is area under the curve. In this case, we're going to use area under the curve because that's what we were given. Okay? So f of 5. So now I'm going to come to my f of x. Every time I see an x, I'm plugging in 5. So f of 5 is 2 plus the integral from 0 to 5 of f prime. Okay. The area from 0 to 5 is 20, and it's all above the x-axis. So that will be positive. So that's 20, and I have this 2 here. So f of 5 is 22. Now we're going to do the same thing for f of 10. Now everywhere we see an x, we're going to replace it with 10. So I start with 2 plus the integral from 0 to 10 of f prime. Okay, well I have an area of 20. Then I have an area of 6 that I need to subtract, so that will take me to 14, plus an area of 4 that I need to add, so that'll be 18. But then don't forget to add this 2. So 18 plus 2 is 20. So I've got 3 y values to check. I've got 2, 22, and 20. The largest is 22. Okay, question 22. It says it's given us f prime, it's already factored for us, and then we want to know our relative extrema. So let's go ahead and just jump straight to our number line, because I can tell I have critical points at 2, 3, and 4. So if I pick a value less than 2, like 0, I get a negative times something that's always positive, right, times a negative. So ultimately I have a positive, okay? That takes me all the way to x equals 2. So I'm going to come here. That has an odd multiplicity, O odd, O opposite, okay? That takes me all the way to x equals, that's for that entire interval. That takes me all the way to x equals 3. Coming over here, that has even multiplicity, so even stays the same, okay? That negative is for this entire interval. That takes me to 4, which has an odd multiplicity, O odd, O opposite. Okay? So f goes increase to decrease. There's a max. Then it continues to decrease. Then it goes back to increase. There's a min. Okay? So let's read our options. Relative max at 2. Yes. Relative min at 3. No, I have neither min nor max there. Relative max at 4, no, so it should be only one, sorry. 23, the graph of the even function, meaning it's symmetric with respect to the y-axis, consists of 4 line segments as shown above. Which of the following statements about f is false? So let's just go through them until we find a false one, okay? So limit as x approaches 0 of the quantity f of x minus f of 0 is 0. Well, since f is continuous, the limit as x approaches, find the limit there, right? I can split that up. So the limit is 0, minus, and then f of 0 is also 0, which is 0. So that's true, okay? For part B, let's try plugging in 0 for this piece, right? So notice that I would get f of 0 minus f of 0 over 0, which would be 0 over 0, which is a do more. The do more that works every time is L'Hopital's, okay? So let's try derivative of the numerator. So term by term, derivative of the numerator is f prime minus, now f of 0 is a constant, right? F of 0 is 0, and the derivative of a constant is 0. Now take the derivative of the denominator, that's 1. Okay, so I'm getting f prime of x, right? And I'm trying to evaluate this at 0. So now let's go and see. What is the derivative there? If I try to zoom in there, do I get 0? I do not. The derivative does not exist. So this is false, making B the correct answer. All right, the radius of a circle is increasing. At that instant, the rate of increase in the area of the circle is numerically equal to twice the rate of increase in its circumference. Okay, so in other words, dA dt is equal to 2 dc dt. What's the radius of the circle at that instant? Okay, so let's first make sure we've got our formulas. The area of a circle is pi r squared, and the circumference of the circle is diameter, pi times the diameter. Diameter is 2r. Okay, so now let's apply the calculus. So derive both sides with respect to t. Notice that like a is a function of time, the radius is a function of time. So the derivative of the left side is not 1, it's a prime, okay, or dA dt. Same thing here, the derivative of the right side is first 2 pi r, but r is like an f of x as well. So it's also times r prime, or dr dt. Okay, let's do the same thing for circumference. So take the derivative of both sides with respect to time. So it's dc dt equals, if this were just deriving with respect to r, it'd be 2 pi. But it's not r, it's deriving with respect to t, so I need to multiply by dr dt. Okay? Now, we know, we said in the beginning, that the rate of change of the area is twice the rate of change of the circumference at this particular time, okay? So dA dt is 2 pi, just plug it in now, 2 pi r dr dt. Then I've got this 2 here, and then dc dt is 2 pi dr dt. So we're going to get nice cancellation here. I can divide dr dt from both sides, right? I can divide pi from both sides. So I get 2r equals 4, so r is 2. Okay, 25 is kind of similar to 24 in the sense that you're deriving with respect to x, but you've got some y terms tangled up, so it's another implicit differentiation. So notice here, you've got product rule, right? So derive the first with respect to x, that'll be 2x, hold the second. And then plus, now switch it, hold the x, derive the y, but y is f of x, right? So the derivative of y, or f of x, is f prime, also known as dy dx. All right, now, let's see here, we've got minus 3x, so the derivative there is just minus 3, because we are deriving with respect to x. And then we've got equals, and then the derivative of, like if that were, right, f of x cubed, you'd have 3 hold the inside, then times the derivative of the inside, right? That's what we're doing here too. So 3y squared times the derivative of the inside, dy dx. You're deriving with respect to x. You're assuming y is a function of x. Derivative of negative 3 is 0. Okay, now, don't go all algebraically fancy on me. Immediately from this point, plug in the point, okay? So I've got 2 times negative 1 times 2 plus negative 1 dy dx minus 3 equals 3 times 2 squared dy dx. So let's see, 2 times negative 1 is negative 2, so this becomes negative 4. That becomes, I dropped a square there, that becomes plus dy dx minus 3. And then PEMDAS here, 3 times 4, so 12 dy dx. I'm going to put an understood 1 there. All right, so negative 4 minus 3 is negative 7. subtract 1 dy dx from both sides, making this 11 dy dx. So final answer is negative 7 divided by 11. 26, don't worry about it. I don't want you to be scared of derivatives of ln and all that, but this one you really have to know. Your algebra skills need to be pretty darn good. So this is one where we don't have to make anywhere close to a perfect to get a 5 on the exam. So this is one it's not worth our anxiety, in my opinion. So you don't need to correct this one. All right, it's a pass. 27, it's our favorite kind. You have a function defined by an integral, which is an antiderivative, but then you're asked to derive it, right? So that means you're going to get back to that integrand. So every time I see a t, I'm going to replace it with the function 2x. But notice I put a function inside another function, so don't forget chain rule here. Multiply by the derivative of the inside function, okay? So now, this is f prime of x. So for f prime of 2, we are going to plug in a 2. All right, so I've got 2 times the square root. Let's see, 2 times 2 is 4. 4 squared is 16, and then I've got another minus 4 there. So we have 2 times the square root of 12, which I do see as an option. Excellent. Question 28, inverse sine of 5x. Okay, so notice you need chain rule here. Outer is inverse sine or arc sine. Inside is 5x. So let's just recall the derivative of the parent function, arc sine of x. So remember, they both arc sine and arc tan start with 1 over. Sine starts with s, so square root and subtraction, right? And then 1 comes before 2, right? So there is the derivative of the parent function. Now, I'm going to replace anytime I see an x with 5x, so that will be the derivative of the outer holding the inner, then times the derivative of the inner, and the derivative of 5x is 5, and that's a 5. And now I think you can match that to e. Great job, y'all.